Hello everyone, this is Pranav and I have with me Teresa. We are data science students from Praxis Business School, and this is a small video on creating a local package for univariate analysis using Python. The prerequisites for this video include the basic understanding of Python data structures, data visualization, data manipulation, and also basic understanding of statistics.
Data cleaning is the most important step in any data science project. Univariate analysis is the first step of data cleaning, that is by plotting histograms and box plots for numeric variables and bar graphs for categorical variables. In a practical scenario where there are a large number of variables, it is a tedious task to plot graphs for each and every variable separately. So our objective is to create a function that automates this time-consuming process. This will give us more time to analyze the graphs rather than spending a lot of time in generating the same.
For the demo purpose, we have taken up the cars dataset. We'll be explaining the columns one by one. So the first column is the cars column, which basically defines the name of the car. Then comes miles per gallon. Then is the number of cylinders of the car. Then comes the displacement, horsepower, the weight of the car, acceleration, model, and also the origin of the car. Before we dig into the Python code, let's have a look at the output. We have a folder called plots in the D drive, which basically has a histogram and a box plot for all numerical variables and a bar graph for all categorical variables. These are the box plots and histograms for acceleration. These are the one for cylinders, and just like that, there's a separate file for each and every variable. And apart from the plots, we have also created a summary file which describes data on the basis of the count of the variables, the unique number of unique values, the top value, the frequency, mean, standard deviation, minimum, the different quantile values, the maximum value. And apart from that, we have also shown the number of missing values in each one of the columns and also the potential number of outliers in each of the columns. For demonstration purposes, we'll be deleting all the output files that we have created till now. Now, let's have a look at the Python code for the local package, and we'll be following an iterative approach for explaining the features of the function one by one. So we have created a function called myfunction_0, which takes in one data frame as an argument. We have imported the package pandas and numpy for data manipulation and seaborn and matplotlib for data visualization. Next, we look at how to plot histograms and box plots. So basically, it considers each element in the data frame and plot a histogram for the same, and ultimately saves in the name variable name underscore histogram.png. Similarly, we can plot box plots and save them as in the respective names variable name underscore box plots.
Coming to the first iteration, the above code is improved by adding an additional parameter called columns, which allows the user to specify the required variables for the analysis. In the second iteration, if the argument columns is ignored, then it will return the graphs of all the variables in the data by default. So the next two lines of code checks if the user has passed any value for columns. If he or she hasn't, all the variables will be stored in the list of columns by default. In the third iteration, in addition to plotting histogram and box plots for numeric variables, we'll be plotting bar graphs for categorical variables, and we split the variables in the data frame into numeric and categorical variables in such a way that all the variables having more than 30 unique values and is of data type float and integer, those variables will be considered as numeric variables and the rest as categorical variables. In the end, we plot the categorical variables and we save them as the variable name underscore bar graph, just as we did for box plots and histograms.
All iterations above would create a mess in the current working directory, as all the plots will be saved to it by default. The next improvement allows the user to specify the directory to which the user wants to save the plots. We have passed dir as an argument to the function, which allows the user to specify the directory towards which the file should be saved. And we have used the chdir, that is a change directory function, for the same. Moving on to the next iteration, Uni-Variate Analysis would never be complete without describing the data. So in this iteration, we have created a data frame of the summary of the data and is exported as a CSV file under the name summary.csv.
Analysis on a dataset is incomplete without imputing the missing values. So we calculate the number of missing values in each variable and append it to the CSV file of summaries. After this, we have computed the number of potential outliers by calculating the count of all values which lie outside 3 standard deviations away from the mean. And finally, we append the computed values in the CSV file.
Now that's it with the Python coding part. We'll be saving this function under the name Uni-Variate Analysis 1. Now moving on to the test file. In the test file, we have imported the packages OS and pandas, and using the change directory function, we have set the working directory. In the next step, we have actually imported the Uni-Variate Analysis 1, the function that we have just created under the alias R. In the next line, we have imported the cards dataset into a data frame called cards, and we have accessed the data, that is the my function using the function r.myfunctions, and have passed the right arguments. And if you run the function, and before you run the function, let's go to the plots directory. You will be able to see that the plots directory is currently empty, and when we run the function, and if you go back to the plots file, you will be able to see that a histogram and a box plot has been created for each numerical variable, and a bar graph has been plotted for each categorical variable. And apart from that, if you open the summary file, we will be able to see a description of all the variables in the data frame, their count, unique values, top, the quantile values, the maximum values, and also the number of missing values in each one of the columns, and also the potential number of outliers. Thank you.